Welcome everybody. I'm Bob Poland. It's a great honor to introduce Anwar Shaikh today. Probably he needs no introduction for almost everybody here. I'll do one anyway. Anwar is University in Exile Professor Emeritus of Economics at the New School for Social Research. We know the New School has been a bedrock of political economy for generations and is a comrade of UMass Amherst in that endeavor. And Anwar has been a mainstay at the New School in political economy for something like 50 years. Now, how is that possible? I've thought about that. You must have started teaching when you were a teenager. But there it is. He's still going strong. I can personally attest to Anwar's contributions as a New School professor. Why? Because he was my professor. And I probably broke a record. I took 5 classes. 5 different classes I took with Anwar Shaikh. And how could you have 5 different seminars? Well, I took Advanced Political Economy 1. I took Advanced Political Economy 2. I took International Trade. I took International Finance and a seminar on Rudolf Hilferding. 5 classes. So there you are. And I'm just one of many, 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 many others who were fortunate enough to have him, including our 2 other New School. Did you take him too? Oh, okay. So we've got any more? I've got 3. I've got Patrick. I've got Ahmed. Oh, we've got 4. We got there. And how many on Zoom? Probably another 185. Okay, so his research contributions, as we know, cover a formidable range of topics, just to list some of them. International trade, finance theory, political economy, econophysics, US macro policy, the welfare state, growth theory, inflation theory, crisis theory, national and global inequality, past and present and current global economic crises. Anwar brought together a good share of all of these topics in his 2016, fair to say, without hyperbole, magnum opus, Capitalism, Competition, Conflict, Crises. Just want to read briefly from one of the many, many reviews of this book, the one that appeared in New Left Review, probably the leading left political economy outlet for general readers, and I'll just read a bit of it. Anwar Shaikh's Capitalism offers the prospect of an intellectual renewal more comprehensive than any so far attempted. Both the range and the depth of his book, covering in detail mainstream and heterodox micro and macroeconomics, are without parallel in contemporary literature. Its ambition is not confined to a critique of prevailing doctrines. Shaikh advances corrected or contrasting views supported by statistical evidence of each central problem with which he deals to construct an alternative account of the workings of capitalism and recent economic developments, particularly in the United States. The scope and scale of capitalism, the book, are such as to invite comparison with Marx's Capital itself. And it is a measure of Shaikh's accomplishment that it appears by no means absurd to apply that standard. Pretty good. Yeah, so we are, again, most fortunate to have Anwar here, and he's going to be giving a 2-lecture series today, and then a week from today, next Tuesday. The topics related are some startling patterns of the empirical distribution of income by race, gender, and class in the United States today, an econophysics explanation. And then next Tuesday, some startling patterns, same thing, but within nations, an econophysics explanation. So we have a lot of people on Zoom, yeah? So we will let Anwar speak after I get done here. And then we will have questions both from here and people online. We will try to divide it up. So without further ado, Professor Anwar Shaikh.
And thank you. It's a real pleasure to be here again, especially since I'm now a citizen of Amherst, well, Belchertown. And so I'm around. I know so many people here, and this is my second home, starting 50 years ago when many of us, like Sam, created ERPI out of annoyance and hostility towards orthodox economics, and we've continued that path, not exactly flowing with prizes and money, but anyway, it's a solid path. I think of us as the Protestants in the Catholic Church. So we have the right argument, but they have the money. I've been working on these subjects now for 10 years. Partly because I work slowly, partly because you have to figure out answers to the puzzles that you find. As Bob mentioned, my goal at all times is to have the theory consistent throughout, so that I don't invent monopoly power. I mean, it does exist, but I'm going to argue that the market is really, really powerful, and it produces patterns, which Adam Smith called the invisible hand. And I'm going to show you some astonishing patterns. And that's because they were doing theory by looking at the real. They were not doing theory by idealizing capitalism and then complaining about how imperfect capitalism was or imperfect people. If you do it that way, you're imperfect, not the subject of investigation. It's the investigator. And you don't see that in Marx, you don't see that in Smith, you don't see that in Ricardo, and you don't see that in Keynes. So from my point of view, these are the four great empirical economists, great theoreticians who developed their understanding from confrontation of economic and political phenomena. And my book is big, 1,011 pages, because I needed to cover the main themes in economic analysis. And it took me 16 years because I had to cover all these, I had to read, I had to find data. When I was struggling with the issue of the theory of interest rates, it took me a couple of years before I saw the light. And the light was fortunately someone else who'd done it, which is always helpful. So I was able to put that together. So in the process, about 10 years ago, my brilliant student, Amr Ragab, came to me and said, I'm bored, I want something to do. And he worked with the UN on the UNDP HDI, Human Resources Income. And so he knew all the data, the World Bank database, all know how to use it, which I had no idea about. He taught me about distribution, which I didn't know much about. And we started doing the work, and we got a pattern which I said, no, can't be true. It's just not possible to have the same pattern across every country in the UN database, 60 countries, it's just not possible. So we started doing it again, and it was true, but then how do you explain it? My problem always is that I have to explain it from a consistent theoretical framework. So we did eventually. I ran across the work of a man named Viktor Yakovenko, who was a physicist. And I'm going to talk about his work here, but he had an explanation of the distribution of income in advanced countries, which came from the market, not from politics, not from changes of government, not from Bill Clinton or any of the Ronald Reagan. It came from the market. And that is the point of view that always struck me as crucial, coming from the classical tradition and from Keynes. But we didn't have an answer. We couldn't figure out what this was. So I began reading, and I ran across Viktor Yakovenko's work, and I saw it was like an explosion. There it was. He was a physicist, so he was not applying it to economics in that sense, but it was a brilliant analysis by class of the distribution of income. And then I applied it to race and gender, which I'm going to show you here briefly. And then I came back to the problem that started us all with distribution of income across the world. I hope you'll find this at least as interesting and puzzling as I did for 10 years. So let me start with that. Lecture 1 will be on the actual income by class in the United States. By class, it means wages and asset income. But fortunately, the IRS has data that breaks down what's called AGI, adjusted gross income. And we found it, and you can see that wage income is the dominant part for the bottom 97%. People, workers, and people like me don't get a lot of income from assets. The top 3%, everybody knows, Saez and Piketty and many others have pointed out, are a different class. That's a good term, it's a different class. And their money does not come from their labor, it comes from the activities from and money from things they created. Maybe they created, maybe they inherited. It's not clear that Donald Trump created his billions, but he certainly inherited a lot of it. On the other hand, Elon Musk created it. So their income comes from that, and that's the old argument about earned and unearned income. But they would say they earned it, but not through labor, through the labor of constructing their assets, perhaps. So it turns out that the top 3% has a radically different distribution of income than the bottom 97%. And this is Yakovenko's observation that just lit up a bulb in my head, because it was basically talking about difference of labor income and capital income, the old story. So when I saw that, and I saw that he had developed some amazing way to treat it, what he found is that the bottom 97% followed a distribution. Let me start the other way. The top 3% followed a distribution, which is called a power law. Now, it's actually called a Pareto law because young Pareto, that one, got his first job analyzing the income of the rich for taxes. They couldn't analyze the income of workers because there were no records for it, and workers' income were not sufficient for the state to take. And what he found is that the income of the rich across Europe followed a pattern, which we now call a power law or a Pareto law. And economists seized on that, but there is empirical evidence, but they found that the rest of it didn't fit. So they tried to make distributions that fit both, and not very successful. Yakovenko comes and he sees this and he goes, wait a minute, this is composed of two distributions. The bottom one, which is an exponential, what the physicists call thermal, because when particles mix and settle down in maximum entropy, they create a distribution, which is an exponential. The other is called superthermal. I'm not sure what that means, but it gives you a power law. And so they tried to explain the economics phenomena through physics. But that doesn't really work. Physics says that particles collide and they exchange energy. So Victor proposed that when people collide in the market, one person gives the other some money, so there's a gain, and what they gain, they lose. That's a particle exchange. And you can derive the empirical pattern, but it makes no sense. So And Victor admits that he's a very good guy, a good friend now. So that was one of the things on my head. How do you explain these patterns? But the other thing is that these patterns hold in every year of the data, without exception. IRS data, and then when you start looking at other countries, people, physicists have found it. So we know that the pattern is deeply embedded. And because it holds in every year, it cannot be due to the policies of the government. Kamala Harris didn't create it. Trump didn't create it. Reagan didn't create it, because over all their years, you'll see exactly the same pattern. And that pattern is for pre-tax incomes. That means that it's before the interference of the state, so to speak, the effect of the state on the distribution of income, which is a good way to look at the theory of markets. The income that is created by market, what Adam Smith calls the invisible hand. So I'm going to show you here is the invisible hand. And then in the next lecture, I'm going to come back to the thing that got me going in the first place, Amherst's treatment of the distribution of income across countries. And we found, again, a very powerful, simple law, which gives you different interpretations of the patterns we found. To tell you one thing, I don't know how many people know the Human Development Index, but at one point, Amartya Sen said the Human Development Index doesn't cover for inequality. So he produced a model based on a assumption of how distribution of income worked, and he proposed that they adjust the Human Development Index by a number, by a variable to adjust, because it's an inequality variable. So here you have the development variable adjusted by inequality. But he had to use assumptions involving neoclassical notions of what people do and what would be a just distribution of income and all of that. And it got really attacked, and it was withdrawn. Now, it was a particular number, a particular variable. And what we found when we did this data on distribution of income across nations, that number has a simple meaning, and it can be derived instantly from one number. I'm not going to tell you how, so you can come to the second lecture, but you will see that it follows from what I'm talking about now. So this now stretches into the domain of the adjustment of income across nations by inequality. And it's a natural adjustment, has a very simple meaning. I showed it to Amartya Sen, and he said, I don't understand things like that, so I pretty much cut it off. I'm not sure that's true, but I 30. So, as I said, Viktor Yakovenko took the overall distribution of pre-tax income, and he recognized that it has two parts. You look at it this way, right? I'm looking at it, yeah, this way. Oh, sorry. It has two parts, the top 97% and the bottom 97% and the top 3%. The bottom representing wages. And we actually later did work to show that the bottom does represent largely wages. I'm going to come to that. And the top, as we know, what everybody's analyzed, the rich are really different from us. They have a different source of income and all of that. So since they apply in every year, they cannot, in my opinion, be constructed by policy. They come from the market. They what Adam Smith, this is Adam Smith's invisible hand. It creates a distribution without the intention or even knowledge of the participants. And yet it's there every year. And by the way, it's in other countries too. The physicists have done a lot of that work, and I can show you some of those sources. So my understanding is that these are processes intrinsic to the market. At one point after working on this, oh, by the way, the original paper, which was by Amar Raghav and myself, was rejected by every journal for 10 years. They all spoke of it with contempt because it didn't have any social welfare function, and it didn't use the distributions and all that. I'm used to contempt, but it was annoying, definitely. And eventually it got taken by a good journal. So I'm going to show you the patterns, and then I'm going to tell you how to derive them from the obvious principle of arbitrage. Now, arbitrage means, in the classical sense, that if wages are higher in one area, then other workers will tend to flow in that direction. So that's called a movement in the equalization in one direction. But along the way, they encounter lots of problems. Some don't make it, others turn back, some collide with some of their opponents. That's called diffusion. So they drift towards the higher wages, but in the process, collisions create diffusion. So that's the Fokker-Planck equations for labor, because they come from physics from the beginning. They're about drift and diffusion. The same principle can be applied to profit rates. Capital moves towards higher profit rates, but never simply as in neoclassical fantasies, but through collisions and reversals and so on, and they create a drift diffusion pattern, but this time for profit rates. It's a different pattern because it determines the different. And interest rates. So he and I, mostly with his tutelage of the mechanics for me, were able to show that we can fit the observed patterns in this very simple way, the invisible hand way of Adam Smith. Okay. Lecture 2, as I said, will come back to this issue, but now income across nations, a World Bank income database. And as we'll get there, we'll find that you can have a set of simple rules. If you give me one number, I can tell you the per capita income of the bottom 70% in any country. One single number. It's a number you're familiar with, simple variable, and it's always true. And we do the same thing for 80%, 90%, where you can see that. Now, at the bottom in developing countries, the bottom is murky because there are lots of problems in the market there and lots of social inhibitions, but in the advanced countries, no. You can see it all the way down. It would be good to look at it in China, for instance. I don't know much about that, but my colleague Ying Chen does. When we were doing this, Joseph Stiglitz said, well, I'm not convinced that this data that you're using, bottom 97%, is mostly wage income, because everybody has some asset income, their savings, and maybe they rent the house. And fortunately, a mere 5 years later, we encountered the data of the IRS. There was a table, and the table broke down adjusted gross income, AGI, which is what you normally use for these variables, into wages and different types of capital income. I was thrilled. And so we looked at that, we took out the wages, and sure enough, the wages is the exponential part. Some of the capital income is fake. They're corporations that list themselves there. They're not people. But if you look at the people, you see that the capital income is a power law. So this, we're identifying this not by the top and bottom percentages, but with the actual income. And that was also something we wrote about. I must say that I couldn't have done any of this without my students. Noe Wiener, who's here, Amar Ragab, Armando Alvarez, Juan Jacobo. These people not only work with me, but they taught me a lot. And that was one of the privileges of being at a place like the New School and here, where you have a population that cares and is skilled. That's not a trivial difference. Okay, so the crucial variable in all of these is a variable called the cumulative distribution from above. Now, if you take a probability distribution, you can easily look at the percentages in each tranche, each bin, and from that you can calculate the distribution from below, and from that you calculate the distribution above. I'd like to show you how it's done because it's, in this audience, people are familiar with it, but if you're not an economist or you don't do statistics, you won't be. So I need the first table. Yeah, that's it. Okay, great. We don't have a pointer, right? So it's all right. And you get it from the IRS, it's on their website, it's for every year, so you should do this, you should try this. It's quite extraordinary. IRS gives you bin size, they already give it to you. They have data for under 2,000, 2,000, 4,000, all the way up to 1 million to 1.5 billion, 1.5 to 2 million, 2 to 5, 5 to about 10, and then 10 or more. Okay. 10 million or more. Now, 10 million or more, they don't have an upper limit because you're not supposed to know who's in the 10 million or more. So they leave the upper limit. And that's something I'm thinking about is whether we can find data that gives you roughly the average income in people who make 10 million or more. You know, Syed's or Piketty, one of those people, but I don't have a number. So what you do is you take the number of returns and you divide them by the total number of returns in each category divided by the total, and you get a frequency. So in the category of under 2,000, there's about 4.5% people. And as you go down, you can see that in the category of 20 to 25,000, there's 3%. 75 to 100, there's 13%. You notice that it peaked. 2,000 to 5,000, 10%, and then 2.5%, 0.4%, and so on as you go up because you're looking at a thin population. Can I do that? Is it here? Of course, sure, of course. Okay. Allows you to calculate the midpoint, which gives you a point on the bottom of the graph. That's a distribution graph. So you need the points for each of these. And then the frequency is simply the number divided by the total number of returns. So that gives you the frequency. And then you need the cumulative frequency, which is the first one. Then the second is the first times the second. The third is the second times the third, and so on. So you're just adding the frequencies as you go down. Is that clear? So as you're going down, you're calculating a number which eventually will come to 1 because in the end, you've picked up everybody. This is called the cumulative frequency from below. However, for Yakovenko's, not for the algebra, for the beautiful graphs, you need the cumulative frequency. There's a mistake from above, which is 1 minus this. So this is 0.044, this is 0.9554. It's very simple too. Obviously with a spreadsheet, you just plug them in and you get all this. So this distribution from above is what Yakovenko looks at, because in physics, that distribution, cumulative distribution from above, captures an exponential as a straight line in a log linear scale, and it captures an power law as a straight line in a log-log scale. So you can look at the data in this simple way, and you can tell whether it's an exponential or power law. Just like that. You'll see how powerful this technique is for visually, because it's stunning when you look at it. Okay, so any questions about this? I didn't know any of this when I started, so don't feel bad if this is unfamiliar. I learned this from my students, yeah. I'm sorry, you have to speak up a bit. No, they do file, but the IRS doesn't want you to know because you might be able to identify them. All of these are people who have to file, all of us, right? But when we get to over $7.5 million as income, there's a sparse population. And you can see that if the population is sparse, a clever person might be able to identify the income of individuals. And so the IRS essentially top codes it, it takes it out so you can't see it. Now, there may be sources where I could calculate this number and it would fill it out, but it turns out that's not going to change the pattern. It's just going to give me one more point. Does that answer your question? No, you're required to file returns. If you're making under 2,000, I'm not sure. But they do have returns under 2,000. Look at the numbers. They have 6 million, 6.5 million. Yeah.
I assume many of them are also household.
No, these are individual.
Married, people, I mean.
No, individual incomes. The IRS can separate them. Because otherwise you'd have a combination of two people. So, yeah, these are individual incomes. When you file as a household, your individual income is listed there, by the way. So it's not like they don't know.
These tax units these are individuals, right?
Pardon?
Aren't it 45 million tax returns? I assume these are not individuals, but these are tax units. So
These are adjusted gross income by the IRS. It's on the basis of which they tax you. So when you file your return, they look at all your incomes. They make some adjustments, which I could talk about later. But this is the standard source of income data by the IRS. And IRS knows everything. Don't kid yourself. They know everything. So they can break it down because you have to break it down to convince them, right, that this is justified. And they do a lot of checking too. I mean, it's not that they just accept your word for it. And there's manuals on this, yes?
I might be about to ask a kind of silly question. What's the significance of calculating it from above as opposed to from below?
Good question, and I'm going to show you. It's because there's no difference in the sense that these are simple calculations from the data. However, if you want to look at the data, it's beautiful to see that if from below you get a straight line. And so you don't need to worry about fitting a function or anything like that. Bang, it's a straight line. And if you take out, income changes over time, the average income, because country grows, and inflation changes the money income. So if you adjust for inflation by taking, say, 2001 real dollars, then that takes out inflation. And if you adjust for the average income, so you're looking only at the distribution, they all fall on the same line. That's Yakovenko. No, it's a mixture of two curves.
Okay.
The Lorenz curve was an attempt to fit one thing to this curve. I'm going to show you. They're two distinct curves. And now you could try to fit it, but the nice thing is you can see the distinction of the curves. They're absolutely linear in their own domain, and they're linear in every year, so you don't want to try to force them to fit into the same clothing, so to speak. I mean, I should say that typically when Pareto discovered the power law, which is for the top, just for these people here, well, it's a bit here. From here down below is the top. That's a power law. So on a log-log scale, it's a straight line. But here, then people try to fit one curve to both. And it doesn't work. But it does work perfectly if you take two curves representing two different class incomes. I asked Victor, how did you think of that? He said, are you kidding? I'm from the Soviet Union. Everybody knows that capitalism has two classes. Okay. And how do I do that? Page up. Oh, I need to go down. Page down. Okay. So now, what we did in a curve like that is we took the cumulative gross income for the bottom 97%, which is simply looking at the numbers to see where they add up to 97%, the bottom of the graph is. Should I do that just to make sure you know? Let me do it so. Okay. Oops. Oh, okay. I want to go back up to the previous graph. Okay. All right. So here, if you look at the cumulative frequency, here is the bottom 97%. It's actually here from below. And above that, starting with 350 is the top 3%. Straightforward, right? You can see that from the data. You add up the cumulative frequency and it tells you here where the bottom 93% is, and it tells you up to here, and then the top starting from 350 is here. So that division is done by the data. You don't look around to see what looks good to you and all that. The data tells you. Is that questions? Okay, so now we go to the data itself. And this is the data on a log linear scale. And a log, if I give you an exponential distribution and you take the logs of it, you get a linear function. Now, that is the data for 2019, and that is a straight line. I mean, you wouldn't need anything complicated, just plot the data and you'll see that's a straight line. If I go to the next graph, and I take the cumulative frequency from above for the top 3%, that's not a straight line in the previous curve because that curve is log linear, but it's a straight line if you take a log, because that's a signature of a power law. And here you can see, this is actual data, by the way, for the US. It's a straight line. So this very useful way, no, you don't need econometric and statistical function in R squared and Bayesian econometrics. I mean, you could do that, but if you're able to see it, you can pretty much see it. Now, I'm going to show you that it's the same in every year. Not that they sit on top of each other. They do if you take out the average income and inflation, but otherwise they're all straight lines. Any questions about this? Sorry, I didn't see it. Yes.
We have one question on the Zoom asking you to clarify how the frequency is calculated.
How the frequency is calculated? Let me go back. I did that, but let me go back. Okay, so the frequency, you have data on the number of returns in this under 2,000. You use the bin midpoint to create a in okay, so here the frequency in the bin is simply the bin, what is it? Number of returns by the total number of returns. It's a percentage of total returns in that bin. And you can go down and see that there are fewer, this is the frequency, the fewer returns when you go to 2 to 4,000, so the frequency is smaller. That's simply taking this column and dividing it by this number, and you get here. But we want cumulative frequency. So what we do is we take the first one is that, and the second is the sum of these first two. The third is the sum of the first three, or the sum of the previous one plus that. So it's just a cumulative process. Is that clear? So that gives you that, and then what we really want is that from the top. So we want this minus 1, so it gives you that. This minus 1, that gives you that. And all the way down here, that's 1 minus 1, so the frequency, cumulative frequency is 0. Okay? Yeah. Oh, shit.
Yeah. Sorry, another very stupid question, but like why, when you're looking at top 3, now even within the top 3, it could well happen that it is much more concentrated towards the lower end in some countries, and so the top
Okay,
3 could
but
be
I haven't
different.
come
So-
to some countries. Right now, we're talking about the advanced country. I'm going to show you that it's true in other advanced countries. And then when we come to the World Bank database, yes, there's some noise there, but you'd be astonished how close it is. What happens in the developing countries, at the bottom part, the data is not good. People don't, list their income for very good reasons. And so as you go further down, the World Bank creates data in some sense, but it doesn't create with this in mind. So it's astonishing that you get patterns like this anyway. Does that answer? Okay, so we go down again. Okay, as I said, if you take the bottom, the cumulative frequency from above, but you take the bottom 97%, which is the income of labor, you get a straight line in a log linear curve. That's a signature of an exponential. I'm going to show you data for every year, but this is just for you to see the pattern. Any questions about this? Okay, then we want to look at the next one, which is the top 3%. We know from other data, which can be calculated, that the top 3% income doesn't come from labor, it comes from assets, because it's very large compared to, pardon? Oh, sorry. It comes from assets, not labor income in the sense of a wage. And here, what you have to do, I have a pointer. I don't know what I did with the pointer. Okay, thank you. Backwards. So here we have log and log. See here, this is a log scale, and this is a log scale. And the data fits a straight line. Not an exact straight line, but it's a pretty damn good straight line. I mean, if they cared about this, Yakovenko should get a Nobel Prize, because this is really beautiful, really beautiful. So this is in constant dollars, so we take out inflation. And that means if you compare over years, we're taking inflation out. So now we go to the third one, I think. Yeah, okay. So this is many countries. All the countries listed here, 1996, 7, 8, 9, 2000, 2001, and 2002. Yeah. Oh, yeah, sorry. Yeah. I had a lot of trouble creating the graphs so they could fit. Okay, good. Perfect. Can you see that now? Okay, well, I don't blame you. I thought I could do this, but I tried it in PowerPoint. Better? Or I'll read it out to you. It's like Braille. Okay, so I'll just read it to you. This is the full data set on a linear linear scale and a linear scale and a log scale here, because In both of them, you have to log scale on the vertical axis, right? Now, this is the data for the bottom 97%, which is like around here or here, I don't know. Yeah, I think here, because it's 350 roughly. And you can see that the different years fit on essentially the same curve. Now, I haven't taken out the level of income, which Yakovenko does. And when you take out the level of income, they fit on the same damn curve. Because when you're doing data like this, you have to adjust for inflation. That moves in nominal terms up, which we do, taking $2,000. But the shape of the curve is different from the level of the curve. And the level of the curve has to fit, so to speak, the average income, real income. And so you can fit that, and he does. But I didn't want to do that because I was sure you'd think I'm cheating. So anyway, this is the data as it is. And given what I showed you, you can calculate this easily. The IRS has the data. So here is your exponential. And here is the power law. This is the top 3% of the same data. Cumulative probability from above, which is the same thing here, but here we have the log of the income. It's a straight line. So this is an exponential, and this is a power law. Okay? As I said, it's the same in every year. You have to do the work to collect this, and you might try this. These are published papers, and I recommend that you go to the IRS and try it or update it. At some point, I get tired of doing the same thing, and then I move on to another question, but there may be interesting things to see here. So what we've established in all the different years, and we've only taken some, in the US, the bottom 97% follows an exponential distribution in cumulative probability from above. And the top 3% follows a power law in the cumulative probability from above. And these are the two signatures of an exponential and a power law. Any questions here? Yeah. Of course, because, and we're going to come to that, because the form of the income is different. In other words, we don't do this by just saying, well, we like this number and cut it off. Yakovenko pointed out that the bottom 97% income is dominated by wage income. The top 3% is dominated by capital income. Stiglitz asked the same question you'd asked. And so we found the data, and we show that's true because we have data on wage income and capital income from the IRS. But I didn't know that at the time I was doing this. And that's a paper maybe we already did it, I don't remember. Either we did it or we're about to do it. And you can show that the bottom 97% has this power exponential distribution, and we can show that it's almost all wage income. And the top we can show has the exponential, has the power law, and almost all of it is capital income. Okay? So we're not just doing it by looking at what we like. The cutoff is different. I'm sorry, 90 and 10? I can give you the data, but the point is if you do it in the two different scales, you'll see the point. Right? If you do it in the exponential scale, you see the top 3% doesn't fit. If you do it in the power law scale, you see the bottom 97% doesn't fit, but it does fit the exponential. It doesn't fit the power law. And the nice thing in looking at these graphs is you can see it right away. You don't have to do econometrics to identify the breakpoint. It's in front of you. And I like stuff like that, you know. Okay, so I've ended by saying that this turns out to apply in every year in the United States, for which we have IRS data, and we have a lot. And it applies in other advanced countries. I haven't done that myself, but Europe, Japan, developed countries where the market, so to speak, is strong. And I've argued before that if this is true in every year, it's evidently not produced by the government policy. It's produced by the market. This is Smith's notion of the invisible hand. Nobody wants an exponential distribution. Maybe they do, I don't know. Nobody wants a power law. That's what they get. And the question then was, what could possibly account for this, given that all the governments in the world are not sitting down and saying we'll have an exponential distribution? And that's the invisible hand. I don't know if I can, I don't know, I didn't derive it here, but there's a paper with Juan Jacobo in which we showed that this notion of drift, lower wages going to higher wages, lower profit rates going to higher profit rates, combined with diffusion, so that as people go, they spread out from their original goal and hit different places. Drift diffusion equations give us exactly this, exponential and a power law. Okay? Now, so I go down to the next one. Oh, we did that, right? Yeah, okay. Yeah. That's, yeah, we did that. I think I duplicated it. Yeah, I did. That's all right. Bottom 97. No, it's okay. I did it twice, so it's okay. As I said, these curves that I showed you before were adjusted for inflation, but not for the average income of the country, which grows over time. If you take that out, then the straight lines really fall on each other. So that's really a natural distribution. It doesn't explain growth, but it explains what the market creates for the distribution. I want to talk a little bit about the relation of this to discrimination. This is not a product of discrimination. It's a product of some market processes. Now, people may be unevenly placed in that because they are not given their proper place through various barriers. And that would be their distribution in this law. But the law itself is not produced by the factors of differentiation among individuals. That's a very important point because discrimination looks at the difference between people that are equally situated in the sense of income and education and experience and sees what their difference is. This looks at it only in terms of their place in income. So what that means, the first one is looking inside that space of having the same income band and taking the average, and discrimination looks inside that average to see the differences among them. Now, these are obviously things that can be combined. It would make a big difference, in my opinion, in discrimination analysis if there was a sense of what the market was creating. Any questions here? Yeah.
Hi. I guess I have somewhat of a math question, but because you mentioned the Fokker-Planck equation, and you just mentioned that, well, workers have a sort of drift process working, or that sort of guides their interaction, and then capitalists have a more diffusion sort of process-like interaction. And another thing in the Fokker-Planck model is that this diffusion is non-local. So, for instance, if you're talking about temperature, you have to define temperature at a certain place by what the temperature is all over the set where you're considering this flow. So I was wondering, maybe this there's a non-local character to this process in the sense that capitalists might be benefiting from the competition between workers. There's something that It's outside the interaction of capitalists with capitalists or workers with workers. I don't know if that's maybe.
No. That's a short answer. Because drift is a force that moves you from, let's say, low profit to high profit, right? They're seeking. But the diffusion is a series of collisions. And we can't, we know that when you observe a process with many collisions, like particles, you get a distribution, but you can't necessarily track each particle because there are many interactions. However, that's the whole point of the Fokker-Planck equations. If you have drift and diffusion, they produce the characteristic patterns. And what I'm arguing is that when we talk about workers moving from low to high wages, you're talking precisely about drift, but lots of collisions with circumstances, other workers, prospects, their families. I think of this as a caravan problem. When I first came to this country, I was too young to go into school, so they kept me a year, and I watched movies about caravans, you know, Americans going from the east to the west. I later got a real aversion to what they were actually doing, but it was very romantic at that point because they would go and some make it, some didn't, some got killed, some changed their mind. And so the process was not a simple movement, but a series of collisions. And that's true of profit even more so. Capitalists go to an arena hoping to make more profit, they may get wiped out. So we can't, this does not model the individual elements, but it models the overall process. And we know from many, many processes that these kinds of collisions produce a pattern that nobody intends. Cars stopping an accident produces a characteristic pattern. The size of cities is a power law. Well, why is that? We don't know, but it's a pretty stable power law. So there's something going on. Okay, in this case, we model it in a very simple way, in a logical way, which is drift and diffusion. Other questions? Okay, so I think that's it. Do I have anything more? Okay, so now I want to come to implications. My screen is showing it. I didn't intend to put that up, but it's okay. You can. We were talking about how when you watch movies with subtitles, you end up reading the subtitles and you have no idea what happened in the movie, but you do know what people said. So I didn't want that, so I'll say it now, yeah. Sorry, you need the mic.
Yeah, I guess the diffusion drift model thing, how does this relate to the kind of process of equalization of profit rates?
That's a very good question, and it so happens I have an answer to that, but you'll have to read my book, because the answer can't come from your head, right? You have to observe the real phenomena to make that judgment. And I have lots of data on the equalization of profit rates of process. And it is pretty much as Smith and Marx and Ricardo, especially Marx, he says, well, it's overshooting and undershooting. A firm that enters a market with good profitability may go there, but other firms come in as profitability comes down, and then it may go down, and then the process may repeat itself, unless, of course, it dies, it's extinguished. So it's not, no one firm is guaranteed some kind of wave, but collectively you can see these waves. And we actually look at the time involved. By different industries, it's obviously different times. So it's a good question. Any other? Okay, so let me now move. How much time do I have left? Yeah, okay. Yeah.
97%. Does it change over time? Does it change across economies?
It's always the bottom 97% because...
So even in Italy, it will be 97. In Togo, it will be 97.
Oh, no, that's a different issue. No, this is the US.
Yeah.
But it's 97 because in the US, the percentage of people who aim mostly wage income is about 97%.
Has it changed over time?
Pretty much, because well, this is a very big sample. And to put it another way, the rich are not like us. They really get their top 3% through a series of assets. It's not exactly 97%, but if you do this, you'll see that the bottom 95, 93 is a straight line in a log linear.
Because I was thinking in the process of economic transformation, there must be a way in which capital takes up a larger and larger share of the economy, and then if that income is not, the income that's not coming from labor will be increasing. So is it the case that that is over time, or is it changing?
No, but it's not about the size of the income. This is not about the size of the income, rising or falling.
Income that comes from.
Yes, you can look at that, and it's pretty much stable. I mean, Yakovenko says, look, it's roughly 97%. And you could probably draw the line a little bit, but you can see if it's between 95 and 97, and there's a straight line here and a straight line there, there's not much you can gain by that. And I encourage you to look at that data. I mean, I have it I have it in spreadsheets actually, but it's easy to look at. What I showed you on that little sheet is from the IRS. You could download that any year. I'm talking about the income of a share of population.
Yeah, so it's the 3% is the population.
And 97% is the
As
population.
the population. And I think what Leonce is asking is, does the share of the 3% change in the overall distribution?
Yes.
So that.
Yeah, absolutely.
So,
because
so it's just that the rule of the distribution is different.
I didn't get that. You're quite right. It does change, and you can see that. But the nice thing is that the share changes because, think of this. No, I'm going to not do this right. If you look at the bottom part of the curve, which is the 97, he makes that as an approximation. We don't, but it's remarkable how much that's a good approximation, the top 3%. But as he points out, those join points can switch according to the relative probability. And I did a paper on that actually on Piketty, showing that that's exactly right. So you're right, Leon, that is exactly correct. But my concern is that they bend like a hinge. And that's astonishing to me, really astonishing. And so if you correct for the average income, Yakovenko does deal with this, and he shows you how much that is. And he shows you, for instance, where the stock market is doing well, that top portion goes up. When it's doing badly, the top portion down. The bottom doesn't change that much because they're not affected by phenomena like that. So that's exactly right. Thank you. I don't have much experience with that top 3% except analytically, so yeah.
So if you're saying that the process of drift and diffusion guides both the labor market and the market with the...
I'm sorry, you have to speak up, yeah.
Oh, okay. So if you're looking
The
at...
microphone is not on, I don't think. It doesn't feel like it's on.
Okay. So if you're looking at if you're saying that drift and diffusion explains both workers in the labor market looking for higher wages and capitalists in the market looking for higher profit rates, why is the distribution of income for the 97%, why is that log linear, and why is the distribution for capitalists log?
Excellent question. And the answer is because the profit rate is a composite of profit and capital. So you have to take that into account. Whereas the wage is a wage related to the amount of labor. So when you model these, you can model them. You have to model the properly. One is a ratio, the other is not. You get these power laws. And we do that, Juan Jacopo and I do that, and we show that the combination of these two gives us this join point and all, empirically and theoretically. But you know, this is work over 10 years. It's not like I woke up one morning or we woke up and saw it. We saw the question. We began to think about the answer. And as I said before, working with students has been enormously for me. I don't think I could have done it. I know I couldn't have done it without the help and guidance of people smarter than I am. It really comes in handy. Okay, so. Sure. Those are the hardest questions, as you know.
If I had to explain this to my grandmother, would I say that capital income is more unequally distributed than wage income?
That's a good question. What does that mean, unequally distributed?
The shape is different, right?
The shape is different, yeah.
And the shape is a more unequal, I mean, reflects greater inequality.
Well, the shape is different because one is an exponential
Yeah.
and the other is a power law.
Yes.
And so I think you're right. The power law could be some index of distribution.
And isn't a power law inherently more unequal than an exponential?
I don't know the answer to that. I haven't thought of that. You've seen this much more, but
But-
probably, but it's not clear because the incomes are higher.
Yeah.
They're more unequal within that.
Yes, that's right. That's the point, that,
I
that
don't know the
capital
answer to
being
that.
more unequal than.
I'll give you the data, you tell me.
Okay.
I'm not sure how to assess that, is what I mean. Now that I think about it, yeah, we could take the Gini coefficient, the bottom 97%, and the data is easy, and the top, and I think you're right, you'll find the Gini coefficient much higher for the top than the bottom, but I didn't think of that, so it's a good question. Probably, yeah. I'm sure you're right, I didn't think of that, that's a good, so can we write a joint paper? The three of us, we can do it, we can do it.
So thank you for the presentation. A very quick question. So you emphasized what is like singular in this
You have
process.
to speak up, I'm sorry, I can't hear you from here.
Is this better?
Yeah.
Okay. So you emphasize that what is somehow singular is that across countries, across years, you always are able to fit the distribution to this pattern. And like you explain a great part of that to the existence of this arbitrage, for instance, among workers. But even
And among,
if,
in capital too, don't
yes,
forget.
among capital.
It's a universal principle, but it's a different operation
Sure,
according to your assets or labor.
But let's just focus on workers, for instance, right? Even if we abstract from policy and let's say just about the technological change that occur in capitalism, right? So this technological change, they are featured by creating, let's say, temporary rents for some, let's say, skills, right? So you have some technological change that somehow creates a high demand for, let's say, computer engineering, and you have a constraint, right? Because it's not just equalization is not possible because you have, let's say, a shortage of skills and that you create a temporary rent. So it's somehow surprising that, I mean, this is kind of inelastic, right? So you should expect that up to the point in which the, let's say, the supply of skills adapts such that you have that equalization, you should observe some change in this pattern that...
I don't think so, because it is not about individual capitalists succeeding or not. That's part of the diffusion. Some succeed, some fail. The question is, what is the distribution of profits? And the distribution of profits can be fairly stable because some people are making these successes, we looked at that, and others are failing. For every success, there has to be a failure. We can't all succeed. When the market's going up, yes, we all succeed. When it's going down, we all fail. But any moment of time, that mixing and turbulence is a mixture of successes and failures. And at a statistical level, that mixture can be fairly stable, even though the individual particles, so to speak, that's the physics point of view, particles may move up or down. And that motivated this originally was the observation that particles, like in sunlight, dust particles, are bouncing around crazy. But when you look at their distribution of energy, it's a stable distribution. So obviously this is true for a big enough sample. You can't hold it for Elon Musk, for instance, but you can look for all the people he killed along the way, right? So that's the other part of that. And it may be that, yes, when you look more concretely, this is not correct, but the point is that this is a characterization of the whole. And it's not clear to me that technological change affects profits of everybody. I mean, it benefits somebody, loses others, right? And that constantly shifting back and forth. So my inclination and looking at the data is that the result is the same, though the individual particles in there are not, obviously.
I guess that maybe this is a question for the next part of the lecture.
In which
in
case, I won't
October.
answer it, so don't worry.
Yeah, I guess, are you able to observe this? Maybe this is, difficult to ask, given that data is probably difficult to come by, but are you able to observe this kind of stratification emerging out of historical or alternative economic systems? Like, would you be able to observe how this emerges out of feudalism, or in the wake
not
of the fall of the
feudalism.
Soviet
This
Union?
is not about people. This is about the dominance of the market. I'm not saying this is what King John wanted to do. This is what markets do when markets run the economy, right? And that's fairly reasoned. That's in capitalism, but advanced capitalism. But let me tell you a story where they don't work, where this doesn't work. In World War II, Hitler's rise to power took place with strict restrictions on what capital and labor could do. And if you didn't like what you did, you paid a big price. So those restrictions allowed Hitler to run huge deficits without inflation, because he told capitalists, you don't want to raise prices, I won't like that. Workers couldn't raise wages, same story, and banks couldn't raise interest rates. So they froze the three key feedback variables, and they did very well. So did the US. Roosevelt did exactly the same thing in World War II, and the budget deficits, which are the highest ever recorded of any capitalist country, no inflation, no rise in wages, no rise in profits. All of that was channeled to growth. So yes, you can break that. And I don't think there's data for that period that we could look at what happens with the break, but yes, you can break it.
If I could give you a couple at the same time, kind of on the distribution of the income data. This one says, are the compensations of CEOs considered wages in IRS data? The dynamics of such compensations have been very different from the rest of wages in the last 30 years. Do we need to account for that? And if I could give you one more at the same time, asking about how to think about home ownership among the bottom 97%. Do we need to think of rent that people aren't paying as an asset income, or is there another way to account for that?
Okay, good. Let me take the second one first. There are people who rent out. They have home ownership, but they don't make any money from that. You have to pay a mortgage, so you're losing money on that. But they can rent out. The national income counts do not treat those people as people. They treat them as businesses. And so in the national income counts, there's this huge number, which is the income of what's called the real estate sector. But it isn't the real estate sector, it's private homeowners, because they have to treat them in some way, and they treat them as corporations. So when you do income data, national income count, you have to be very careful to realize that that is a constructed number. And people know that, but and there's a debate about that. So when I do national income counts, I take that number out because I made it up. Now, there is an income that goes from ownership if you rent, but that's a pretty small number. And yes, and there is detailed data, by the way. You could take it out. And I don't think it's going to change the distribution because it's a small number. Now, when you get to actual corporations, that's a different story. And the trouble is that actual corporations are not people. This is personal income. For some cases, they're treated as people, but you can take that out. I mean, they're treated by the IRS or national income accounts. I'm not sure the IRS. And you can take it out. It doesn't really change the distribution of income, though it changes the distribution of corporations. And IRS has that data split out. So if you want to do it more carefully, which we did, it doesn't change the results. I mean, nice thing of saying 3% and 97% is a nice hard line, which gives you these very strong results. So whatever else you're talking about, they are flowing around this pattern. Yeah. Oh, there's one more from the, yeah.
Derive their income from Social Security pensions and annuities. Is this in the analysis as income from labor? If not, then how does the percentage of pensioned elderly in a society affect the distribution?
Well, if you think about it, your pensions come from your past labor, right? Mine does, that's for sure. So it is a transfer of your labor income to the present as a stream, by the way, not as a lump sum. So IRS data includes that in your adjusted gross income. They have a lot of other things, and you can take it out, by the way, but they include that. But keep in mind, this only affects a portion of the population, people like me. It doesn't affect the numbers below who haven't received it, haven't come to wherever they can get this, say, age of 70 or 67 or whatever. And that population is not big, and when you take it out, it doesn't change the basic results. But I encourage you to do that. I mean, as I said, the IRS, we found, after 10 years, we found the IRS publishes this data. Nobody ever told me that. And so you can do that. You can see, you can play with the different things. It's very exciting. I mean, not everybody gets excited by this kind of thing, but I do.
Thanks. How does the sum of all income from the income statements in the IRS relate to the net product? Like, is there a category that's missing? Does the sum of all income from these tax returns equal GDP?
No, these are personal incomes. GDP is essentially the income of corporations and wages and some other things that they add in. But it's not, I mean, you can find a relation between the two, but this is personal income.
So profits that are retained by corporations are not included in the IRS data?
No, because this is income of persons, and corporations are not persons, except in the Republican Party, but I mean.
Thank you for a fascinating paper. I'm really curious about the physics analogy and the nature and significance of that analogy. So I presume that it is an analogy because you mentioned that physicists are observing processes that lead to these distributions in particles, and I presume the invisible hand doesn't have that direct power over particles, but if there's an analogous mechanism at work in their models, and maybe if there's any other sort of drift distribution processes that we can observe in non-human nature. I'm curious about whether how far the analogy stretches and what is the significance.
It's not an analogy, it's a mathematical tool. It's not an analogy at all, because you can do the same mathematical tool for many different processes, right? So the drift diffusion model was based on particles, not living things, and the collision of particles and drift. I'm talking about the collision of people and drift, but the point is that that same process appears not even intentional. You don't really intend to have the caravan model make it to California or not along the way, but intervening factors produces, and we know that many, many human and non-human processes produce similar patterns, some of which we have no explanation. So if you look up distribution of income, distribution of outcomes, Pareto is the most common, exponential, power law. It's astonishing how many things distribute patterns. For instance, I said the size of cities is a power law. I have no idea why, and they don't either, but it's true. And so this leads you to think about why it might be true. In my case, I spent a lot of my time studying the classical economists who talked about these processes as human processes, but colliding. And that's a word that comes up, collision. Well, that's drift diffusion. Excuse me.
I had another stupid question. I'm just thinking, if we are on that log linear line, does interpersonal distribution of income have to remain the same as you move along? You'll remain along the line, but you can have a different Gini coefficient over time.
The Gini coefficient, no, because the Gini coefficient characterizes the whole line.
Yeah, but the points along that line, because you're fitting a line, so you could have some points on top.
Of this exponential distribution is 0.5. It gives you a 0.5. So the variation in the Gini comes from the top, and Yakovenko discusses that and analyzes that. What's so interesting is that the Gini coefficient of income of workers is 0.5.
Across time.
Everywhere. We do it for the next talk. We're going to talk about how it varies across countries. It's because the join point can tilt. And as profits come up higher, gas that way is less, and that accounts for the range of Gini coefficients we have. It's very interesting.
Just following on from that and from what Leon said, you described it as a kind of hinge, which is a nice way of looking at it, right? The bottom 97 and the top 3. So does the position of the hinge and the angle of the hinge change over time? In the US,
It's not a hinge
countries.
per se, but if you think of the bottom as a exponential, the top is a power law, then obviously you have to connect the two. Yakovenko shows a very beautiful way to connect them simply. And that allows you to characterize the whole distribution depending on, as you said, the tilt of the hinge. Because the bottom doesn't change, it's a Gini coefficient 0.5. The top does, because profits and other things affect that, and he shows that.
So, no, but both. So one is that the top changes, the shape of the top changes, but also does the position change in terms of the overall distribution? That is the share of the top 3% increasing over time or something?
Well, think of it, the way that this thing is created, you're going from the bottom percentage of people up to 97%, right? The next one will be a hinge because it's 98 and 99. So there'll be a curve here. But that curve is is a power law rather than the bottom.
No, I'm granting, I'm talking about a different thing, which is the share of that 3% in
yes.
the total income.
Absolutely does.
It does.
I happen to have written a paper on that.
Exactly. That's what
criticizing Piketty's treatment of that. Because this has a very beautiful, simple way to treat it, which is that the share of that is the profit share. And if you think about the wage share is the bottom, the profit share is the top, the hinge, the wage share, at least the distribution, is a Gini coefficient 0.5, but the profit share doesn't have that. And the overall Gini coefficient depends on the profit share only, which is really cool. Nobody says cool anymore, but I think it's cool.
That's really interesting, Anwar.
Thank you.
Couple of questions. One, there's a great variety of temporal capitalisms in America. You had the Gilded Age, you had the Keynesian, Fordist Keynesian period, then you have the neoliberal period. And during the Fordist Keynesian period, there was severe regulation, right? I mean, of financial capital. So how does that alter? I mean, this model. So are you saying that even when there are very significant policy interventions, this particular distribution, this 97 and 3% doesn't change at all across these 150 years?
I didn't say that. The bottom 97% does not change, and you can look at it in the data. It's easy. The top depends on what's happening to profit share. So what I did in that paper and comment on Piketty is I can derive the overall depending on the share of profits to wages. So there's your intervention by capital and by the state and all of that. But it's not a big movement, by the way. The Gini coefficient does not shift much over time because you're talking about the effect of the top 3%. And that's something interesting too, because when you think of the Gini coefficient as a composite of a 0.5 and a variable, you can see that that variable cannot range very much without the collapse of capitalism, right? So that accounts for the small variation in Gini coefficients over time.
So, a second question, why are pre-tax incomes interesting? Because, you know, a lot of social processes alter, you know, the final income distribution. So in itself, you know, maybe there is a pattern, right? And there is an enduring pattern. But, you know, by focusing on pre-tax incomes, are we taking the larger social analysis out of the picture and allowing, you know, something like physics to tell us something about society, which
No, I
it
don't
cannot
think so.
beyond
I
a
don't
point?
think so. I think it's just the opposite. If you take pre-tax income, you're taking the base on which post-tax income sits, right? Without that, you can't say post-tax income this and that if you don't know what the base is doing. By showing that these patterns are universal in the sense that you have the coefficient at 0.5 and the profit share, then you can start talking about the aggregate income effects of policies. You can also look at the income effects on pre-tax incomes by taking post-tax incomes. I haven't done that, but it's an obvious thing to do. I don't know the answer to that. But what does different states of policy have on the difference in the curve, so to speak, right? Because the Gini is the whole curve, and the top also. And I'm absolutely agree that that's where your policy analysis comes. But it's so important to know that it's operating on a bedrock that's pretty firm. The market has this distribution for both sides, and you're operating on the hinge point, so to speak, and they can move. But that accounts, I think, for the fact that Gini coefficients don't move a whole lot.